In this example, we are going to apply some of the limit laws to compute a limit. In this particular case, we are going to be taking a look at the limit as x goes to 1 of this polynomial function here, 3x to the third plus 2x minus 1. So first off, we are going to apply the limit laws that we saw in the first part when we talked about limit laws. We are going to, we have a sum and difference of functions here. So we are going to use the limit laws that say I can take a look at the sum of the and difference of the limits here. So I'm going to split this up into 3 parts here. Then we're going to use the constant multiple rule that says if I have the limit of a constant times a function, right, I can pull the constant out here and compute this limit and just multiply by the constant. So I'm going to do that in this location here and this location in here. Okay. Next up, I am going to apply one of the limit laws from part 2, where I had a function raised to a power. So in this case, I have an x inside here, and it's raised to the third power. Right? This limit law says that that is the limit as x goes to a of just whatever the function is raised to the nth power here. So in this case, right, I had the limit as x goes to 1 of x to the third power. So that is going to be the limit as x goes to 1 of the function x raised to the third power there. And all of these limits that we have here, the limit as x goes to 1 of x, right, it would just be 1. The limit as x goes to 1 of x would just be 1. The limit as x goes to 1 of 1, right, that's a constant, so that would come out to be 1 also. So what I would wind up with is this limit is 1, so I'd have 3 times 1 to the third power plus 2 times 1 minus this limit here, which is 1 also. And that, if you simplify all that stuff out, that comes out to be 3 plus 2 minus 1, so 5 minus 1, which comes out to be 4. So again, we just sort of systematically apply those limit laws and to come up with the answer here. And again, you're probably saying, well, look, that is exactly what I would get when I plugged in a 1 for x right here, and that would be absolutely correct. And in fact, this is a polynomial function. Any polynomial function can be, the limit of any polynomial function can be found in the same way here. So this is pretty straightforward. You do have to be careful, right, and don't jump the gun and think that every single limit problem can be found that way. It just doesn't work that way. But again, we'll see a little bit later on that a lot of the functions that we care about in this course, that they do work in that way. So.